Let us look at proposition number 65 of book 10 of Euclid's Elements. The proposition says the square on the side of a sum of two medial areas applied to a rational straight line produces as breadth the sixth binomial. So here, let AB be the side of sum of two medial areas divided into its terms at C with AC greater than BC. So understand what we are starting off with. The AB is the side of sum of two medial areas, which we are dividing it into its terms at C. Set out DE a rational straight line. Apply a parallelogram DEFG to DE equal to the square on AB. Now, when we do this, this produces a breadth or width DG. What the proposition is saying is DG is going to be a sixth binomial. Okay, let's prove this. Apply a parallelogram DH equal to AC square to DE, and then apply a parallelogram KL to KH. But remember, KH is equal to DE. So we can say apply a parallelogram KL to DE. Now, since DL is AC square plus BC square, the remainder will be 2 times AC by BC. That is MF. So which means if we bisect MG at N, then MO and NF will be each equal to AC by BC. Now, based on the characteristics of these two side of the sum of two medial areas, we can say AC and BC are straight lines incommensurable in square. AC square plus BC square is medial, and AC by BC is medial and incommensurable with AC square plus BC square. DL is applied to DE, DL is applied to DE. So which means DM is rational and incommensurable with DE. Since AC by BC is medial, 2 times AC by BC, which is MF, is also medial. And a medial area has been applied to DE. Actually, it is applied to ML, but ML is again equal to DE. So we can say MG is rational and incommensurable in length with ML. So MG is incommensurable in length with ML. That is DE. So AC is incommensurable with BC, and AC is to BC is equal to the square on AC is to AC by BC. So AC square is incommensurable with AC by BC because AC is incommensurable with BC. And because of this proportionality, we can say AC square is also incommensurable with AC by BC. AC square plus BC square is incommensurable with 2 times AC by BC. That means DL is incommensurable with MF because DL is nothing but AC square plus BC square, and 2 times AC by BC is MF. Remember, DL and MF have been applied to DE. DE is common to both these DL and MF. So that means if DL is incommensurable with MF, the other side, that is DM, is going to be incommensurable with MG. So DM and MG are incommensurable in length. Therefore, DG is binomial. Okay, AC by BC is the mean proportional between AC square and BC square. MO is the mean proportional between DH and KL. MO is what? MO is this, which is AC by BC. And AC square and BC square are what? DH and KL. So that is how we can say MO is the mean proportional between DH and KL, and that can be written in proportionality form like this. Now, since the areas DH is to MO is equal to MO is to KL, that means the sides will also be in proportion. So that means dk is to mn is equal to mn is to km, and we can multiply the extremes and multiply the means and they will be equal. So we can write this as dk by km is equal to mn square. dh is incommensurable with kl. dh is incommensurable with kl. Why? Because dh is ac square, kl is bc square, and ac and bc are incommensurable. So which means dk is also incommensurable with km. You know, ac square plus bc square is greater than 2 times ac by bc. That means dl is greater than mf, which means dm is greater than mg. So dk by km is equal to mn square, and mn square is nothing but 1/4 of mg square, and dk is incommensurable with km. What this means is that dm square is greater than mg square by the square on a straight line incommensurable with dm, and dn and mg are incommensurable in length with de. So we can say that dg is a sixth binomial straight line. That is the proposition number 65 of book 10 of Euclid's Elements. Now, in the last 5 or 6, I think 6 propositions, the structure of the construction and the proof is same. The only difference that comes is depending on what we start off with, its characteristics, and based on that, we arrive at what we need to prove. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.